So first we are going to see lap joint. Okay, lap joint or connection. So the lap joint, see, the lap joint means there are two plates which are connected one over another by means of a connector. The connector is either bolt or rivet. So this is the connector. This is the connector. Okay. This is the connector. Okay. Now it is subjected to a force P. Here on force P, here on force P. You know, now these two forces are having a eccentricity because these two forces are acting at a certain distance. So this is the eccentricity E. So this is the eccentric connection E. Eccentricity. The forces are not acting axially. There was a certain eccentricity E. Okay. Now this E, which is called as lever arm. Lever arm. So this eccentricity produces a moment about this center point, and that moment produces the bending stress on the bolt, so that this efficiency of the bolt or rivet getting reduced. Okay, so that we are saying the lap joint is the most, that is the least efficient joint. Why least efficient joint? Because of this two forces are acting certain distance, that is eccentricity. This eccentricity will create a secondary stress. That because of that secondary stress, the efficiency is reduces. Okay, so this is about this. Now this is the main plate one, thickness 1 of main plate. This is the another one, thickness of T2 of main plate. Okay, main plate. Now the distance between these two is called as the grip length. This distance, okay, distance between these two is grip length. Grip length, that is LG. Okay, and this LG should not greater than 5 times the diameter. Okay, where D is the dia of bolt or rivet. You can take any one of that. Okay, now what are the important points that you have to keep in your mind in the lap connection? The first point you have to keep in your mind, it is the least efficient joint, because line of action of two forces are not same. These two forces form a couple, and this couple produces additional bending stresses in the plate, produces additional bending stress in the bolt. not a plate. Okay. Next one, as per IS 456 2000, sorry, as per IS 800 2007, the effect of bending stress, the effect of bending stress can be neglected, if the grip length approximately 5 times the D. Okay. Next one, free body diagram. Free body diagram, this bolt, you know, while failure is happen, this bolt broken into two pieces, and other portion gets displaced and somewhere here. Okay. So here there was a bearing stress. Because of this force, there was a bearing stress will be acts in this direction. Because of this force, there was a bearing stress will be acts in this direction. So this is the bearing stress. Okay. And this direction is the bearing stress on the face. Okay. Now see, the shearing stress is this one, this bearing, and this is the shearing. Okay, shearing. Now we can write this is the bearing force. We can write this is the bearing force. Now bearing force means it is exerted, it is exerted by the plate, it is exerted by the plate on the bolt, on the bolt. Okay. Now this is the shearing force. Okay, that is PS. This is PSB. This is PBB. Right, this one. So we can say this is the shearing force. Shearing force, and it is exerted by. It is exerted by. It is exerted by bottom piece of bolt on top piece of bolt due to the action of bearing. Okay, now I have to write here note. Okay, I can write somewhere here note in lap joint, bolts are subjected to single shear and single bearing. Single bearing. In lap joint, the bolts are subjected to single shear and single bearing. Okay, that means only one shear plane. So this is the shear plane. Okay, only one plane. In this plane only the failure is happened, because this is one plate, this is another plate, right? So the shear plane is a predetermined plane. Anyhow, the failure is happening in this, and the bearing also. Any one of the bearing stress will be there, because this is one bearing stress. This is another one bearing stress. The failures happen any one of that is a maximum of these two. At that direction, the failure is happen. So that's why we are taking here also the bearing stress is only one. Only one bearing failure has happened. Either the top one or bottom one. Either this one or this one. So maximum is a failure. Okay, that's why we are saying single bearing. We are not taking into account the two bearing. Okay, maximum is a failure. Okay, now here you have to write that is without, that is very very important, without bearing stress, without bearing stress, this is the bearing stress. Okay, without bearing stress, shear stress cannot exist. Without bearing stress, shear stress cannot exist. So this is also a point you have to keep in your mind. Okay, now we are going to analyze this one, lap joint. Okay, see, let us consider a lap joint. This lap joint will be analyzed in the two way. One is per gauge length, analysis per gauge length, then analysis per full full width. Okay, the first one is lap joint analysis. Case A, by considering entire width of plate. Okay, for considering entire width of plate. For considering entire width of plate, so this is useful for width of plate. Width of plate is less. So this is the first one. The second one, case B. Case B, for considering only per gauge length. Okay, so that is for considering per gauge length. Okay, for gauge length. This is useful for plate width is large. When the plate width is large. So these two cases we are going to analyze one by one. Okay. See, let us take a lap joint first of all. There was a lap joint. Okay. Now let us take a bolt. There are two bolts we can take it as for our analysis. Okay. Okay. This is the bolt or belt. So bolt or rivet, whatever may be. So this is the force which is acting P. This is the another force which is acting P. Okay. Now the plate is, total length of plate is this one. Okay. This is the length of the plate. And this one is the first plate. This is the length of the first plate, and this is the ending point of the second plate. Okay, this is one plate, and from here to here is another plate, and there was a bolt. One, two, three, four. Okay, and this is the width of the plate. This is B, width of the plate. Okay, in the similar manner, you have to draw the same diagram here also. Here I am going to take some more board for your better understanding. Let me take some 6 bolt. Let me take a 6 bolt. Okay, 6 bolt. Okay, 6 bolt. So in the similar manner, here we can take lap joint, and this is the bolt. There are 2 bolt. Okay, there are 2 bolt. Okay, now this is the width of the plate, and this is the ending of first plate. This is the ending of a second plate. Yeah, the diagram is important to make sense the problem very easily. Okay, this is P, this also P. Okay, now let us consider the same 6 bolts are there. 6 bolts are there. Okay, here we are considering the entire width, but in this case we are considering only per pitch, sorry, per gauge. So center to center distance, this one and this one. For this, what is the strength of the plate that we are going to calculate? If we finish the strength of plate for this portion, then we can conclude the strength of the entire plate. Okay, by understanding per gauge length what is the strength, based on that you can calculate the strength of the entire plate. So this is P and this also P. Okay, and here also this is the force P and this is the force P. Okay, now first one we are going to write, that is shear strength of the plate. A, first one is shear strength of, not a plate, bolt. Shear strength, shear strength of bolt or a rivet. Shear strength of bolt or rivet, so which can be written as, we know that what is that shear strength of bolt, P S B, right? We can write P S B, shear strength of bolt. PSB is equal to, you know, which is equal to number of bolt into number of shear plane into area of one bolt, area of bolt into permissible stress, Fy, not Fy, it's a permissible shear stress, F, yes. Okay, Here N means shear strength means what? So there are 6 bolts are there. In that 6 bolt, 1 bolt the resisting shear resistance which is happen on this portion, this part. In this area the shear resistance will be happen because this is the point where the failure is happen, right? Therefore for one shear area, one shear resistance, two shear area, two shear resistance. Okay, now like that there are 6 bolt, therefore 6 shear areas are there. Okay, now we can write this n is equal to number of bolt, or we can say rivet. Small n means number of shear plane. So particularly for example, in this case, how much is how much is the shear plane? For a bolt, for a bolt, one shear plane. Okay, small n is equal to 1. Number of bolt, how much? Capital N is equal to 6 for this problem. Okay, AB is equal to area of bolt. Area bolt we know pi by 4 into d square. Okay, now what is Fs? Fs is the shear strength. Fs is the shear strength of bolt. We having seen shear strength of bolt or weld. Fs is equal to shear strength of bolt. Shear strength of bolt. The shear strength of bolt which is equal to 100 megapascal in working stress method. So which is equal to Fu divided by 1.25 into root of 3 in the limit state method. This is the Fs. Okay. In the limit state method, Fs is okay, and working stress method, Fs is okay. Okay. Now what is Fu? Fu is equal to ultimate tensile stress in bolt. Ultimate tensile stress in bolt material. Okay. Now we having seen about the shear strength of the bolt. Okay. Now we can move further. Bearing strength of the bolt. Shearing strength of the bolt is over. A. Now B. Bearing strength of the bolt. Bearing strength of bolt, or we can say rivet. If I forget to write bolt or rivet, you have to keep this in your mind. Wherever I am writing bolt, there you have to keep this in your mind. Wherever I am writing bolt, there may be a rivet also. You can use this is bolt or rivet. Okay. Now this is bearing strength of bolt, PBB. Okay. Now we can write PBB, bearing strength of bolt, which we can write it as small n dash, small n dash, or here let us take small n into area of bearing into bearing strength of the bolt or rivet. Okay, here let us take this the capital N. Okay, here capital N is equal to number of bolt or rivet. Okay, number of bolt in joint. So how much we are having N is equal to in this case 6. Now AB area, projected area of projected bearing area of bolt, projected bearing area of bolt. This is the area in this the bearing force is acting. Okay, so now if you project it, if you project this to the diameter, so this is the bolt. Okay, this is the bolt. Here the bearing is happened. Okay, in this distance, sorry, in this portion there was a bearing. Okay, so there was a bearing in this portion, there was a bearing in this portion, there was a bearing in this portion. So if you project this, we will get a diameter. Okay, projection means if you draw a rays, then it touches through the diameter of the bolt. Therefore the projected area, which is equal to diameter of the bolt into thickness of the bolt. Okay, where d is the dia of bolt, t is the thickness of thinner bolt, sorry, thinner plate. Why we are taking thinner plate? See, there are two plates are there, one, two. So the bearing stress will be happen maximum where the plate thickness is very less. So where the plate thickness is very less, that means less at that portion subjected to bearing stress or bearing failure as early as possible compared to the thicker plate. So okay, that's why we are taking the smaller plate. So AB is over. Now we can write what is that? FB. FB is equal to permissible bearing stress. Permissible bearing stress. So which we can write 2.5 into KB into FU divided by FU divided by FU divided by 1.25. Okay, in limit state method. So I can write this permissible bearing stress in the next slide so that we won't confuse. Okay, Fs is equal to permissible bearing stress. So which is equal to 2.5 into kb into fu divided by 1.25. So this is the answer in limit state method. In limit state method, which is equal to 300 megapascal in working stress method. 300 megapascal in working stress method. Okay, this is all about bearing stress. So generally this kb we will take, if not given, then we will take this kb is equal to 1. We will take kb which is equal to 1 generally, if not given anything. Okay, but so many things are there to calculate a kb as per is 800 2007. But in the state government or central government examination or even gate examination, we don't explore much thing about kb. Okay, so in the examination they will ask you the whether the students are understanding the concept or not. But if you start to explore, there was a two separate designs are there for rivet and bolt. You have to study rivet in the limit state method separately, and limit state method the rivet separately, bolt separately. Then both the different, the design philosophy and the codal, that formulas are different. But in the examination nobody will ask you. The examiner need to know whether the students are understanding the concept or not. Okay, so now this is about, next one is, in the shear connection, we know there is no shear strength, tearing strength of plate, sorry, bolt. In the shear connection, there is no tensile or tearing strength of bolt is happened. Therefore, you can ignore the tensile strength of bolt. Okay. Now you can write here what is a bolt value. Bolt or rivet value, which is equal to minimum of PSB, comma PBB. So this is the answer. Bolt or rivet value is minimum of those two. Okay. Now next one is TNPSC, tearing strength of, tearing strength of plate. I said the split using the proper end distance. Therefore, we don't have a formulas. For the tearing strength of plate, we have a formula. Okay, so this we can write PTP, tearing strength of plate. So this can be written as PTP, which is equal to minimum of AG into Fy divided by 1.1 or A net into 0.9 Fu divided by 1.25. Ag into Fy divided by 1.1 or A net into 0.9 Fu divided by 1.25. So this is based on gross yielding of plate. This is due to gross yielding of plate at section XX. Now this is based on net area cracking, at 1 okay, at 1 Now what we can do, what is a section XX and 1 So this is the section XX, this is the gross area yielding, and this is the section 1 net area yielding. So what I have to do, I can use some other color so that this is the XX, X, and this is, what is this, 1 section 1 This is the net area yielding, this is the gross area yielding. Okay, that is PTP. Now what is AG? Gross area. So AG is equal to gross area, and we can write AG gross area, which is equal to breadth into thickness. A net is equal to B minus N N1 into diameter of hole into thickness. What is the meaning? So at this section 1 total B, breadth is what? Total B minus number of rivet hole. Here N1 means what? 3 rivet holes are we are subtracted, right? Into the thickness of the plate. Okay. So where N1 is number of bolt hole in section 1 1. Okay, DH is equal to bolt hole or rivet hole. Bolt hole or rivet hole. T is the thickness, B is the breadth of the plate. Okay, so AG is over, A net is over. Now we can say the strength of the joint. Strength of joint or connection. Strength of the joint or connection is taken as minimum of minimum of shear strength of bolt, bearing strength of bolt, tearing strength of bolt. So take minimum of this, which gives the strength of the connection. Okay, strength of the connection. Now we are going to see the bolt value and efficiency of the connection. So we are going to see, this is the tearing strength. Now we are going to see number of D, number of bolt or rivet calculation. Number of bolt or rivet calculation, which is number of bolt, which is equal to capital N factored load divided by rivet value, rivet or bolt value. Okay, so which is equal to factored load, you can take it as a force divided by a rivet value. So what is a factored load? Factored load, which is equal to 1.5 times the working load. 1.5 times the working load. Okay, so this is all about the number of bolt. Now we are going to see the efficiency of the bolt. Okay, we are going to see the efficiency of the bolt. Efficiency of the bolt. D E. Efficiency of not a bolt, sorry, efficiency of connection. Efficiency of connection, that is eta. So efficiency of the connection, which is equal to least value of PSB, PBB, tearing strength of plate. Okay, actually this is the plate. Okay, plate. This also okay, fine. Plate divided by strength of solid plate. Strength of solid plate into 100. Okay, here the least value, generally least value we consider PTB. Why we consider the PTB, that is not a bolt, PTP? Why? Okay. So the reason for this is the connection failure is more dangerous than the element failure. Okay. The the thing is because connection connection failure means bolt failure. Okay. Connection failure is more dangerous more dangerous than element failure element failure. So that is a reason. So if the connection fails, that means the bolt fails, then the entire structure will be collapsed. But if there is a element failure, that is a tearing of plate, only a plate failed, then the entire structure will not be failed. Okay, meaning if the connection fail, if the connection failure cause global failure of the structure, global failure, that means the entire structure gets failed. Element failure, if a single element, that is the plate is failed, then we can say this is the local failure. So only that element is failed, but the entire structure won't be failed. That's why for efficiency calculation, we have to consider out of these three, the plate value is less. Okay. Now, what is now efficiency? What is PTP? So PTP, we can take it as B minus net area N1, okay, N1 into diameter of hole into T, or another one is, this is the net area yielding, another is a gross area yielding, that is B into T, B into T, okay, the whole into, we can take the strength of the plate, okay, the stress in the plate. So we can write that stress in the plate is equal to FT, tensile strength of the plate. Okay, so we have uh, okay, FT into this also FT. Now generally out of these two, this one will be minimum. Out of these two, this is the gross yielding. This is the net yielding. Think about it. We are just subtracting N1 times the diameter of hole value, right? So generally this value is lesser as compared to this one. Therefore, we can take it as, for efficiency calculation, B minus N1 into diameter of hole into F of T, the whole divided by BT into F of T. So cancel out these two into 100. So finally you will get an answer which is equal to B minus N1 into diameter of hole divided by, so cancel out, this is here on T also comes, right? So T cancel, so you will get a B minus N1 into DH divided by B. So this is the answer for efficiency for considering the entire plate. So this is very important examination question. Directly they will ask you. So this is all about the lap joint by considering the entire plate. So for entire plate, this is the formula. Okay, these are the concept. By considering the entire plate, your shear strength of the bolt, bearing strength of the bolt, tearing strength of the bolt. Okay, and tearing strength of the plate. Sorry. Then number of bolt calculation. Now efficiency of the connection calculation. Okay, I hope you understood. Now we can move. We can move the strength of the plate by considering per gauge length. When the width is very large, then we will consider the strength per gauge length. So first one, A. whatever we have written here, the same thing we are going to write once again. That is shear strength of bolt or rivet, that is PSB. Everything is same, but small changes will be there. What is PSB? N into small n into AB into Fs. So everything whatever will be written here, the same thing, the same name will be there. Okay. And here what is a n? Here n is equal to number of bolt. Here number of bolt in the connection. But here n is the number of bolt per gauge. Here number of bolt in the entire width. Here number of bolt in number of bolt or rivet in shaded portion. Shaded portion. So which is equal to 3. Now small n is equal to what? Number of shear plane. Number of shear plane also here only one shear plane is there, right? Now actually it's not 3, only 2. Only 2. Then AB, area of bolt, which is equal to pi by 4 into d square. Okay. Now what is Fs? Fs equal to the same shear strength of bolt, which is equal to 100 megapascal for working stress method. Everything is same. Okay. And Fu divided by 1.25 square root of 3. Square root of 3. This is the limit state method. Okay. Now what is a Fu? The same thing. Ultimate tensile stress in bolt material. In bolt material or rivet material. Okay. The second one is bearing strength of bolt. So we are going to see bearing strength of bolt, or in bracket we can say rivet, per gauge length. Okay. PBB. What is PBB now? PBB is equal to number of bolt in the gauge into AB, area of bearing, into FP. So N is equal to number of bolt in the joint. Here N is equal to number of bolt per gauge length. N is equal to 2. AB is equal to the projected area, D into T. Where D is equal to what? Diameter of the bolt. D is the dia of bolt. T is the thickness of thinner plate. Here only one thing will change. What is that? Only this number of bolt will be changed. All others are same. Okay. Here why I have taken n is equal to 2? Because per gauge length your value is only 2. Okay. Okay. Now everything is fine. Now we can write. Actually, there was a this is Fs. This is FB, bearing strength of permissible bearing stress. Okay. Sorry for the mistake. This is the bearing strength of plate. That is bolt. Okay. Now this is okay. Now FB, which is equal to same permissible bearing stress, which is equal to same value, nothing to be changed, into KB into Fu divided by 1.25 for a limit state method which is equal to 300 megapascal for working stress method. Okay. And bolt or rivet value, which is equal to, we can write minimum of PSB PBB. Okay. And the next one is tearing strength of plate. Tearing strength of plate PTP TP, which is equal to PTP, which is equal to minimum of one. This is based on the same thing. Okay, based on gross yielding of plate at section XX. Let me draw section XX. Let me show here section XX. So this is your section XX, and this is your section 11. Section 11. Okay. Now we understood this. Or A net into 0.9 FU divided by 1.25. This is based on net area yielding or cracking. So net area cracking at the section 11. Okay, at the section 11. So this is all about the tearing strength of the plate. Okay, now we can move further. AG, gross area yielding. There, here we put a entire width, but here per gauge length, width of the gauge length entity. This is the difference between considering entire plate and per gauge length. See, this is the width here. Only we are considering per gauge length analysis, but here we are considering the entire plate analysis. So that is a difference. Okay. Now A net calculation, which is equal to, here entire plate minus n1 in diameter of hole, but here G gauge is a width, n1 is a number of bolt hole. Okay, this is a DH. Per gauge length, this n1 is equal to always 1. Per gauge length only one bolt is there, right? Therefore always 1 always. Per gauge length means for this gauge length, okay, for G only one bolt hole will be there. Per gauge length means always only one bolt. Okay, only one bolt will be present. So n1 is equal to 1 always. You have to keep in your mind. Now A net is equal to 1 always. DH is the diameter of the hole. Everything is fine. Okay, the same as this. Okay. Now strength of the connection. The strength is same here. N1 is you have to take from here. DH is you have to take from here. DH is a bolt hole or rivet hole. N1 is the number of bolt hole in the section 11. Okay, it's very simple. That's why I'm not written here. Okay. So strength of joint or connection is taken as PSB PT minimum of this. That is the strength of the. Now we go before last. Number of bolt or rivet. Number of bolt or rivet calculation, that is we can write capital N. Capital N is equal to same factored load divided by rivet or bolt value. So you know the factored load is equal to 1.5 times the working load. That also you know. Now the efficiency of the connection is equal to efficiency of connection. So efficiency of connection, that is a eta. So eta is equal to least value of PSB, comma PBB, comma PTP, the whole divided by strength of solid plate into 100. Okay, and generally least value we consider, why just the same thing will be, you have to write it here also, but this both are same, right? Therefore only the difference is here the entire width we are considering, but here only the gauge length we are considering. Okay, now the efficiency eta, the same sentence here also comes. Okay, now the efficiency is equal to, therefore instead of B, okay, we can write G, because this is the only gauge length, minus N1 is 1, right? A net N1, that is 1 into diameter of hole into T, or you can take the, we are considering only PTP, right? So that sentences we have written. Okay, BT into F of T, the whole divided by strength of plate, BT into F of T into 100. So generally out of these two, gross yielding, this one is having very less, that is a net yielding is less compared to the gross yielding. So the value is now G minus diameter of hole into T into F of T is F of T divided by, actually this is not a B, sorry, G per gauge length. Okay, so G T into F of T into 100. So the after simplification you will get G minus DH divided by G into 100. So this is your answer. Okay, so with that we finished the lap joint. So the next one we are going to see the single cover butt joint. Okay, so lap joint is over, then the single cover butt joint, then the double cover butt joint. So I will do the single cover butt joint also. First the characteristics of the single cover butt joint, then the case A, case B. That means by considering the entire width, by considering per gauge length. So whatever we have done, okay, this, the same way I will go for a single core butt joint and a double core butt joint. Okay,